Oh, fine, now YouTube started working, I think. Going live, going live. And went live. Cool. Link, link, link. Now the link command will work. And this will help us later to find something when rewatching the stream. This will be the current problem. Right, only division 1, sorry. Because I don't know problem from division 2. Right, let's start. If you're watching on YouTube, just switch to Twitch for live chat if you need one. Strange birthday party. Well, it helps to sort those values k, and then we'll have something like that. Let's analyze the sample test, where we have what? 2, 2, 3, 3 after sorting 4, and also the prices 3, 5, 12, and 20. What does it mean? It means that these 2 should get one of those prices, this 2 also should get one of those, 3 should get one of those, and so on, but nothing can be repeated. And if you're out of items, let's say you have some assignment, and now a 3 cannot be matched with anything among first 3 prices, then it gets exactly the third price. It means that it would be very bad for a 4 not to be matched with anything. If we use all of those, I think it's impossible, but if we use them in some way to match with all of this, then 4 will be in very bad situation, will need to pay exactly 20. That's the worst case. And that's true in general for big values. Notice that what we can do is we can match big value. Let's say that this 20 is actually 2000. Then for sure I don't want to use 2000. But I can always match 4 with something on the left, let's say 5. And if I want to avoid big numbers like that, I can, for example, do this. And 2 to 3, even if they are out of numbers, I can always pay 5 for 2, 5 for 2, 12 for 3. Hence the idea that big numbers, like this 4, we don't want to pair it like that. We don't want to use this 200 at all, or 20. So it will be matched with something on the left instead, something smaller. And this is in general true for big numbers, so for suffix of this sorted sequence of case. And hence, we will do something like this. A suffix of this sequence will be matched with prefix of this one. If you want a proof for that, it will be something like that. So I claim that there are those values k, there are prices. Optimal solution will take some suffix of those and will match exactly with prefix of prices. For everything else, we will pay just exactly, if this is value 2, then we will pay exactly that. If this is value 2, we will pay exactly that. This is value 3, we will pay exactly that. 3, exactly that. Okay. So the proof would need to consist of at least 2 parts, where first, if those blue lines, if they cross, so if it's something like that, then we can always swap, because conditions are only easier to satisfy. And also if they don't cover the whole prefix of prices, so there is something skipped, then it's better to replace those lines with these new improved lines. Instead of blue, use red. Because, well, skipped price was smaller, so better. So, again, the main claim is that suffix of sorted values case will be matched with prefix of this, and everything else will just use this other special condition where it said can either buy a present, this will be a suffix, or just give them this. This will be for a prefix. And that's it. I will read questions from the chat in a moment. Okay, how did I implement this? I first binary searched how big suffix can be matched with prefix. I use binary search. I think it's unnecessary because you cannot always say that this is matched with that because values k are your limit. Like if let's say at the end of k you have 1 and 5, you cannot match this with first 3 elements, with first 3 prices, because this means that this can be matched only with the first price, not the first 2. So when binary searching how big suffix I can take, I need to check, and I try, let's say, last 3 numbers, or last 4. I need to check that this is at least 1, at least 2, at least 3, at least 4. This is what I check here. And then I know that suffix up to length, let's say 4, can be matched, but also 3, 2, or 1. And checking all of them is easy. Because if you compute the answer for one suffix, then the next suffix is almost the same. Explanation of that is like you have 2, 2, 3, 3, 4, and prices, whatever they are. If you matched it like this, then this has a cost of 3 plus 5 plus the cost of those, so 5 plus 5 plus 12, easy. Now if you want to consider shorter suffix of just this one red line instead of the 2 blue, you just need to update what happens for this guy and what happens for, well, those. This actually will use just prefix. I precompute prefix sums of prices to know what will be the sum of blue or red lines, and I update a single value when considering suffix shorter by 1. I'm reading the chat for questions. Simpler solution here? Oh, I mean, sure. I don't think I will check out other solutions now. I will show you mine. Sadly, this is what happens when I don't know problems in advance. I'm not an author tester. I don't see any questions that I should answer here. No, I didn't explain division 2. It's just division 1. Let's move on. Why do you need binary search instead of just 2 pointers? Oh, I think we can do it without binary search. Treat this not as intended solutions. Treat this as me explaining my solutions. And I will show you how to solve A, B, C, D, E, because I think I solved E. I got one value wrong in the sample output, but still it's very close, I think. And for F, I will show you an idea. But now we move to problem B. All right. This was kind of a troll problem. LCM and GCD. They tell us that two numbers are similar if their difference, product-wise, is a square. It means that if one number is, let's say, 2 to 5th power multiplied by 3 to 10th power multiplied by 5 to 7th power, something like that, every number can be expressed as product of primes to some powers. The other number will match this one only if it's of form 2, 2, and now here must be power of the same exponent. If this was 5, then this can be 5, 7, 9, 1, 3. This can be in particular 17 times 3 to 4 times 5 to 3rd power times, let's say, 13 to 4th power. Those two numbers are the same because everywhere parity is the same. 5 and 17 has the same parity, 10 and 4 have the same parity, and so on. In particular, you can imagine that there is here 13 to 0th power, and then it's also the same parity. I will not do division 2, because I don't know those problems. I only solved division 1. All right. And they describe some process, but this was the first important thing to understand. Then at every second, a number is changed into product of all numbers similar to this number. So there are some groups. Let's say those two values would be in the same group, and actually they can be, this is called canonical representation. It's quite common if you have groups, you need one represented. For both of those numbers, I will say that its canonical representation is 2 times 5. This is the simplest possible number similar to those. I just care about primes with odd exponent next to them. 2 to first power times 5 to first power. And any number with exactly those primes, not being even power, will be similar to this. So we can read the input, and it will boil down to something like that. There is a number of form 2 times 5, or something similar to it, and there are, let's say, I don't know, 60 such numbers. We count every form after doing prime sieve in order to know this representation for every number. Let's say we also have number 2 times 3 times 13, and that one occurs 4 times, and there is also 5 times 7, and it occurs 3 times. What will happen after a single operation, the compression thing, where everything changes into the product? Well, if we have 5 times 7, and it occurs 3 times, in a moment we'll take product of those 3 occurrences. 5 times 7 will change into 5 times 7 to the 3rd power. So it's, it's equal in terms of our similarity to just 5 times 7. Nothing changed here. If number was similar to 5 times 7, it will still be similar to 5 times 7, assuming that we had 3 occurrences of that. But whenever here we had an even count, it will cancel. Product of 60 values, or generally any even values of the same number, will be a square, perfect square. Like this 10 to the 2nd power already is 100, it's perfect square. Same to the 60th power. So this is 2 times 5 to 60th power, and this is similar to just 1, meaning primes to the 0th power. Same here, this will be 1. After the first operation defined in the statement, everything, if it occurred even number of times, it changed into 1, meaning a prime into 0th power, to 0th power. If it occurred odd number of times, then it will stay. And that's it, there's nothing more. What you need to do in this problem, run prime sieve in order to know forms of every number like this. Then you will know the canonical representation of every number. Like this, you would need to change it to 2 times 5, so value 10. Count occurrences of every value. Check if it's even or odd. And now, if in the query we have 0, because they just ask after some number of updates, what's the maximum degree, maximum number of times something occurs. If this moment, time, number of operations is 0, then we just print maximum of those values we counted, 64 and 3. If it's at least 1, then we know what happened. Those even values, and also the number of occurrences of 1 itself from the beginning, it collapses, and this stays. The situation at time 0 is 64 and 3, the counts, and the situation then is 64, 1 occurs that many times, and still 5 times 7 occurs 3 times. And now nothing more will change. This will stay forever. After reading time from the input, you can minimize it with 1. I think I've got a simpler solution. I don't think there is something simpler than this, maybe. Run a sieve that marked all multiples of perfect squares as items square. Well, sure. I mean, this is just a different way to run sieve. For me, for every number, I wanted to know the representant, and it was something like that. So this is its canonical representation, and when I run sieve, it's like this. When I see that prime I is divisor of j, then I do this. Representant of j is representant of I divided by I or multiplied by I, depending on divisibility, like this. For example, 49 is changed into just 1. So representant of 49 is 1. Representant of 98, so twice that, is 2. If now I do this again, 196, it will be 1 again. You just need to check some simple divisibility. Why not consider pair with second element as 1? I don't know what you're talking about. But the second element of my pairs is how many times something of this form occurs. No board rock. I don't think this is true, what you're asking. Oh yeah, representant of here, j divided by I. Thank you, Mangolassi. So when I want to know representant of 196, and I know some prime, like 2 here at the divisor, then I take representant of 98, and I either multiply it or divide by 2. I see that people keep guessing some formula for LCM. That doesn't matter. I told you the full solution. Alrighty, we move on. Next problem will be C. Strange shuffle. This is an interactive problem, and there is some process described. I will just show you what this process does, if I'm able to. Process. Let's see if this still works. Init of imposter, let's say on position 4. N is 10, K is 100. And what do I want? Process. I will just show you the sequence to then explain what is going on. And process should print stuff. It will. All right. We have it. Just let me increase the font. All right. We start with a sequence of equal values. In this example, values are equal to 100. And then after every second, everybody passes half of its value to the right neighbor, half of the value to the left neighbor with some rounding. But there is one imposter who passes everything to the right neighbor. Actually, I need to do it before, like that. Now it will be more clear. Right. In problem C, we start with a sequence of, let's say, hundreds. And then if everybody passes half of its value to the right and left neighbor, then everything will stay the same. But there is one guy, in this example, it's this position, I think. 4, 0, 1, 2, 3, 4. Yeah, okay. 0 indexed ID 4. And he passes the full 100 to the right. Also, this right guy gets half of the right guy, so it will be 115 total. And the left neighbor gets a bit less because he doesn't get anything from the right neighbor, who is the imposter. This is repeated for like 1000 times, Every time you can ask about single value in this sequence, you don't know the full sequence, and you need to this way, after 1000 updates, know who the impostor is. And printing this helps a lot because we see how the sequence looks like after a lot of operations. In particular, the impostor turns out that because of symmetricity, some kind of symmetricity, the impostor always has the initial value of 100. Values on the right are bigger, values on the left are smaller. Let's see a slightly bigger example. A bit too big. Right? We start with thousands. Okay, that's good. And impostor is here. And let's see what happens after a lot of updates. Values on the left from him are very small, including values at the end of the sequence. The sequence wraps around. Values on the right are bigger than 1000. And the value exactly opposite to 1000 is also 1000. Assuming that n is even or odd. If n is even, then this happens. Right. So how do we go about this? If you analyze this properly for some time, you will see that after k operations, everything in distance k from impostor will be smaller or greater than k. After, let's say, 10 operations, everything in range 10 will be smaller or bigger than the initial value. And we know the initial value. We know that initially everything is 1000. So let's say that there were some updates and then the sequence is frozen. Let's say that forever now it will be this. That's not true. But if it will be this, then we can binary search where 1000 is, where the impostor is, by getting any value. Let's say we got this one, 1300 something, and then we know that we need to go to the left to get bigger and bigger values, and eventually it will drop to 1000. If I see here, I try to jump to the left, I binary search how far I can jump to still have values bigger than 1000. I will find this value and then I will jump by one more. This would be a case if the sequence was frozen, but it isn't the case. Every time it's updated. Lucky for us is that if something is greater than 1000, it will keep being greater than 1000. If we print this some more, let's print this 500 iterations. Like forever, eventually the sequence is indeed frozen. I'm now scrolling. This is a different sequence every row. But this is just because n is small. Anyway, it's not that the values will eventually drop below 1000. And this is just observation from running this process on my computer. What happens if n is big though? Yeah, let's say that n is 200 or 200, and we analyze this, we run this process only 30 times. Then this is single occurrence of a sequence. Most of it will be 1000 because impostor will not be able to reach it in any way. After first operation, impostor only affected the value of the two neighbors. Second operation, only two guys on the right, two guys on the left, and so on. And now let's look at limits in the problem. N is up to 100,000, and we can use 1000 questions. N is up to this, and we can use 1000 questions. Okay. After 1000 questions, or around that time, a range of 2000 items values will be affected. Close to the end, around 2000 values will be affected out of 100,000. Even if we ask randomly about values, most of the time we'll get value equal to k, equal to the initial value, and we know that value. But eventually we will get a value different than the initial value, and we'll know if it's greater or smaller, so we know in which part we are, and we can binary search and go towards the middle. We don't know where middle is. Our job is to find the imposter. So consider this. Keep randomly asking about one value. Whenever you get something different from the initial value, this is given in the input, start binary search in proper direction. Meaning if you have too big value, you need to go to the left, too small, go to the right. I didn't want to go to do this randomly, so instead, if we look at this is my C? Yeah, this is my C. What I did is this. I started asking about index 0, then jumped by 1, by 2, by 3, by 4, 5, 6, and so on. Instead of randomly, I make bigger and bigger jump. You could also just jump by 300 every time, and you will also find it. What's important is that 1000 is significantly more than square root of n. If in sequence of size n, you have some interval of size square root of n, and you need to hit it to find it, and then some binary search, then you need around square root of n operations. So the complexity is this. We need that many operations. Square root of n for the first part to get anything different than the starting value, and then log of n for binary search. If you want to watch in quality smaller than 1080p, you can watch on YouTube. Here's the link. Can I look at problems A and B from division 2? Yeah, sure, I can do. All right, so after division 1, I will look at problems from division 2. Any questions about this? Because we are done here. Please clarify about B. Is it true that two numbers are adjacent if they are multiple of each other in the multiplicative factor? No, that's not true. Consider 2 to third power times 7 versus 2 times 7 to third power. These two are not one divisor of the other, and yet they are adjacent. Let's move on. Problem D now. No, not this one. Strange housing. I don't know. Some problems in this contest I found surprisingly easy. Maybe just I made a mistake. Why will you find a different number in square root of n in the previous problem? Because if you have interval of size 1000 or 2000 and you have something of size 100,000 with jumps of length at least that interval size, you will find it. If you have something of length square root of n in interval of length n with square root of n jumps, you will find it. I'm not a Twitch partner. This is why you don't have an option to downgrade the stream. All right, we have a graph, and I think the statement was very strange. Like this, if there are no teachers after comma, I didn't understand it for some time. But what we need to do is choose some vertices so that, like, let's say we choose 1, 9, and so on. There are some conditions. First of all, you cannot take two vertices that are connected with an edge directly. Second thing is that after you choose some vertices, let's say we chose this, you need to be able to go from any vertex to any vertex only using edges such that one endpoint of an edge is a chosen vertex. And here this is not the case because you will not be able to get here. But if you also choose one of these two, either 7 or 14, we are good. Like this is, I believe, one good solution. As it turns out, the problem boils down to taking some vertex and then saying that its neighbors are also taken. And thanks to that, you will be able to travel between all these 6 vertices. And if there are some more vertices, well, you need to make some more choices. Let's say that this is the graph. We can, for example, take this guy, and it will, cover this as well. Or we can take this one, it will cover this. When I understood this statement, I thought that maybe it's always possible. You need 7 here, because 12 and 14 are adjacent. Oh, you're right. Okay, sorry. This was wrong. Yeah, sorry about that. You need to take this 7. We had a moment ago. We had here adjacency, and that's bad. Sorry about that. 7 needs to be taken. Okay. Anyway, when the vertex is chosen, all the neighbors are covered as well, let's say. And if we cover all vertices, everything will be fine. Is that the case? Not really. Wait. In this case, okay, this is an important test, what I drew below. Here, all vertices are covered, but we're talking about covering edges as well. It's not that every edge must be covered, but you need to be able to travel from any vertex to any other vertex, and this right choice guarantees only this part, left choice guarantees this part, so this you cannot use this edge. Okay. So at this point I thought that, oh, maybe bridges are important, and I thought that maybe we'll need to find bridges. I didn't. I hope that my solution is correct. But I analyzed the samples to see when is it possible that the answer is no. And the only such sample here is actually disconnected graph in the input. After that, I thought that, okay, I'm guessing that it's always possible, and it's some simple DFS, maybe related to coloring of a graph. I have no idea, but it will be easy. Also, a lot of people solved it. After I solved C, I already saw that more people solved D. And this is always, even now, this should be true, right? Yeah. At this point of judging, we have 20 accepted for D and 2 for C. So for sure, D is easy. Right? So what to do about this case below? A different color. Well, I thought that, okay, if I mark randomly, I will mess up. But it's important after, let's say, taking this guy, to take this one next. So if there is here a bridge in this case, it isn't that important that it's a bridge, but let's try to solve this test properly. If this is a bridge, and yeah, using this guy, I covered those, but then I'm right now not able to cover this edge, then I need to take this one. So what about whenever I get to something, greedily taking it if possible? I described to you my thinking process, and yeah, that's it. I just implemented it. I don't know more about this correctness of it. So let's analyze again what my program does. Starts from any vertex and takes it. It has some neighbors. It marks them as covert, or maybe let's think about it as forbidden. You cannot take them, but runs DFS. Keeps running DFS. We now consider neighbors of this guy. Whenever we see not taken neighbors, we take them. Or actually, just we take a single one. So we are now here. We are now here with DFS. This is not yet decided. And yeah, we consider neighbors of this guy. Oh, this is a new. Yeah, because I took this one, I forbid the neighbors. Let's actually see the code for logic. Then we'll get back to drawings. The logic is very simple. This is my DFS. If this vertex is not forbidden, then take it and mark all neighbors as forbidden. Then run DFS on neighbors. Can you do it in constant space? No, you need to read the graph. Right? So again, maybe some new simulation. We have a vertex, not forbidden. Okay, I take it. Then look at every neighbor, forbid them. And keep running DFS. Now we are here with DFS. If not forbidden, then take it. Well, this is forbidden, so I cannot take it. But see neighbors and run DFS on them. Let's say this is the first. Not forbidden. Okay, I take it. Forbid the neighbors if there are any. And keep running DFS. Maybe then this is the next DFS. And so on and so on. Why does this work? This works because whenever we enter, actually I'm not that sure, whenever we enter a vertex, okay, maybe this, for every vertex, it was eventually entered in DFS. Let's consider what happens when we enter this guy in DFS. There are two cases. Either we take it, or we not take it, which means that it is forbidden, which means that there was some previously considered vertex that is taken, like this one. So for sure we are able to get from him to you. Also, when we look at this taken guy, well, we can use edges from him to somewhere else, and there was some previous vertex taken in DFS, and we can use that edge. The proof will be using induction. In DFS, when we consider some vertex, we want to say that all vertices already considered can be visited when going from this starting vertex. Whenever something is forbidden, it means that it was a neighbor of taken vertex, so it's good. Whenever something is taken, it means, well, still, we got here somewhere, it's a vertex of something, and we can use this edge. End of proof. Kubakao, I appreciate that you like my content, but a single message is enough. No need to spam. Is the only case where it's impossible when you end up forbidding a taken edge? I don't end up forbidding a taken edge. No, the only impossible case is if graph is disconnected. Here I presented a proof that if everything is connected, then this construction works. Can you do this in linear time? I do this in linear time. I don't see any non-linear part. Did I do anything in nlogn? That was D. Now, I solved ABCD and got accepted on pretest. In E I didn't, but I think I have a solution, so I will explain it to you. But yeah, be aware that I didn't get accepted. I might be wrong. And also, this is a hard problem. After E and after my thoughts on F, I will move to division 2 AB. How does it matter where we start the DFS? No, it doesn't. You can start from wherever. I started from vertex 1. Yeah. In E, we have a permutation. Let's say that the permutation is 2, 3, 1, 4, 5, 6. And we have some total cost allowed. And this allows us to reverse intervals of the permutations, of the permutation. Okay. Also, limits are n up to something small, let's say 10 to fifth power, doesn't matter too much, but c is up to 4. That's crucial. There are also queries. Okay, we'll talk about queries later. We can reverse an interval of the permutation, and reversing something of length L takes cost of L minus 1. Cost is L minus 1. And we can use that much money in total. This is our amount of money. If C is free, it means that we can reverse one interval of length 4, but we can also do it with shorter intervals, like this one and this one. This will also have a total cost of 3. We can also just reverse this or just do nothing. This is maximum allowed cost. And we need to only do disjoint intervals. We cannot do this and then that. That's forbidden. Right. Now, the problem is this. You're given this permutation and C. Now, consider the list of all possible permutations you can get. Sort all the permutations. There will be a lot of them. I think around n to 4th power. Or actually n to 6th power. That's the magnitude, I believe, of how many permutations we can get. Sort all of them. And then we have queries of form ij. It means ith permutation in this sorted list. What is its jth value? Yeah. Long story short, we need to be able to ask some kind of query about ith lexicographically smallest permutation we can get. Will this stream be recorded? Yes. Everything can be later watched on YouTube. Link is here. All right, how to solve this? When we want to find kth lexicographically smallest something, we almost always go from the left because we first care about minimizing the first value. And I wonder about the various possibilities of what will be on this first position. The first position is affected only by a possible interval we reverse, and that is either not doing anything, or we reverse this, or we reverse that, or we reverse this. I consider those C possibilities. For each of them, I know what will be there, and I can sort the possibilities according to this position. And I will know that lexicographically smallest is to use this interval 2, 3, 1, because then 1 will get to the first position. All right, so cost of 2 is the first possibility, lexicographically best. The next one is just reversing this element with cost 0. Then reversing those two with cost 1. And finally reversing that with cost 3. This should be kind of priority order. And if we decide to do something like this thing, reverse 2, 3, 1, then we will be left with this remaining sequence. And it would be nice to know how many ways there are to also modify it with the remaining allowed cost. This says that we need dp for every length n and every remaining cost. Let's call it the remaining cost. What's the number of possible sequences we will get if we start with sequence of length n, and this is the remaining allowed cost. This way, after applying this operation, I can read from that dp, and it's easy to compute this dp, relatively easy. I will know that, let's say, there are 5 ways to deal with the rest of the sequence. Actually, it's smaller than that, but it's an example. then let's say if we use cost 0, there are 26 ways to deal with the rest of the sequence. Here there are, let's say, 10, and here only 1. Those values are very important, because if you're asked a query with finding k equal to, let's say, 40th smallest lexicographically smallest sequence, it means that you will skip the 5, you will skip 26, that's 31 in total, and you will ask the 9th out of those possibilities. So those are ways sorted lexicographically in this order. We skip 31, we need 9th out of this. So this would mean that we need to do this operation of cost 1, we reverse this, 32, and we move on, and the remaining allowed cost is decreased by 1. Then we move from here, and so on and so on. And like that we can find the whole sequence. Assuming that preprocessing to find this DP is is easy and fast, and it is, then we can answer every query in complexity n, maybe multiplied by some polynomial of, I will write here small, because anything coming out of 4 will be small. And this is too slow. This is not the intended solution. But for every query, I can go through the permutation, look at what will happen at first position, take from dp those number of ways for every remaining situation, and this way figure out to which case I go. Possibly I do operation on those first few elements, and I move forward. Always, the current situation is defined by the current index I, or let's say position in the sequence, and the remaining cost, and the number of ways. Sorry, let's say k, and we are finding the k smallest sequence. Like if we start with k equal to 40, then in this case, we started with position 0, c equal to 3, and k equal to 40. And after doing this, we will be on position 2, 0 indexed, k equal to 9, and c will be 2, decreased by 1 because we made already a single operation. Right? And it's very important that this is very small, cannot exceed the initial remaining cost of 4. This is at most 4. And we will use it to speed up the solution. I don't want to have n in complexity. I want to make a quick jump over a big part where I don't do any operation. So the sequence might be very, very long, but only in at most 4 places I will do something. So if I need to find a sequence where this part was reversed and later this part was reversed, I want to quickly jump over this part to get here, then quickly jump over this part, and then quickly jump over this part. And I will do it with a segment tree. At least this is how I did it. A segment tree built on this, and what I need is information. Let's get back here. This is very crucial row, cost of 0, because this means nothing happens, and almost always this is the option we'll choose. Each of those other possibilities, it decreases the remaining cost, because we have cost of at least 1. At most 4 times, one of those will happen through the whole sequence. I want to jump through intervals with cost equal to 0. And I see here that if k is bigger than 5, but doesn't exceed 31, let's save this interval, from 6 to 31, if k is in this interval, then indeed we will move on. But the number of ways, the k will be decreased by 5. Okay, and this is important information, this interval, and the fact that we decrease by this. In every node of a segment tree, I save this information. I called it it, so by how much the number of ways k will decrease, and some interval, let's call it from L to R. If we are from L to R, then this will happen. If not, then we need to actually look at this part because something interesting will happen. We'll have one of those 4 red interesting situations. Segment tree allows us to quite easily merge those into something bigger, and then I use this technique where when you have a segment tree, one row, it's called, I would say it's called binary search in a tree, where let's say we start here. Those leaves, they represent the sequence. I want to find the next position where I should go to say that I skip all of this, let's say. How to do it in a tree? How to binary search the next position satisfying something? Well, we go up, then eventually down. Every time when we go up and we have a right child, I check if I should go there. And if yes, then I go there. So if I'm not contained in interval saved in this node of a segment tree. If not, then go up. Then eventually we'll start going down, and always, if left node already represents elements of a sequence that would kill us, this means that triggers the interesting red operation, so something will happen, something non-empty will be reversed, then we go there. So that way, in logarithmic time, I will find this place. It means I skipped all of that, and here I will reverse at least 2 elements. Easier version of this technique is where you just want to answer queries for some starting position in the sequence I, find the next occurrence of element at least x. Do this in single logarithm. Yep, that's it. My solution has complexity q times logarithm of n times something small. That should be fast enough. Questions? Is it done? Not yet. I will be around 20th. Could be better. And finally, my thoughts on F. I spent maybe 10 minutes on it. We are given a bunch of points, and we need to find 2 rectangles that together will cover all the points, and we need to minimize the sum of their areas. For example, maybe this will be optimal. Those 2 rectangles together, they cover all the points. I analyzed, I first would find the 4 border points, bottommost, rightmost, topmost, leftmost. If something is in the corner, then bottommost and leftmost might be the same point. So yeah, I start with this, finding the 4 special points, and now I say this. 2 rectangles must in particular contain these points. If one of rectangles contains all 4, that's easy because we know exactly how it looks. If one rectangle contains 3 points, that's also easy because it must look like this. And then the second one just looks like that. And we can cover this case quite easily with a sweep line, because it means there is some sweep line that splits plane into 2 parts, and when a rectangle takes one part, the other part. By maintaining some set with max x, min x, max y, min y, we can do this in nlog n. Also, we should rotate everything by 90 degrees and consider the same with horizontal instead of vertical sweep line, right? What about the case where no rectangle takes 3 or 4 border points? It would mean that either a rectangle takes 2 consecutive points like this, or alternatively, maybe let's make, oh, no. I will hide my face for a moment to show you more. Let's move this to the left. This is one possibility, and the other is that they intersect. Like that. Those are two cases we need to solve, and this will be for sure hardest for this problem. I mean, these two. I focused on analyzing the right one, and what I understood is that after finding the 4 special points, we need to also find not really convex hull, but maximal points between them, which means that there is no point that is worse than me. If you have 4 red points, consider this part of the plane, and there, if there are 2 points, and one is on the left and higher than the other, then this is more important, and we can forget about this other one. You can find this stair-like area, like this, something like that, and only those points are important. You don't care what is here. Okay, so you just find this sequence of interesting points, and then when you choose every point, you can consider as, let's say, the topmost point of this wide rectangle. Then you know everything looks like this. And now you need to efficiently find optimal good opposite point on the bottom part of this rectangle. If we say that it's this, let's say this guy, then we know exactly how the drawing looks like, because now we need to look at those 4 points and just take the boundary box of them, like this. Right? This is, for sure, this already solves the problem in quadratic time, if we are smart enough. Brute force here would be already cubic, because we iterate over this point and this one, and then find minimum x and maximum x of the remaining points. Actually, not remaining points, just these 4. So yeah, this is quadratic. And to do it fast, for every top yellow point, so for this one, I need to efficiently find the optimal other yellow point here. And just when we move with this yellow point to the top to something else, like then here, 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 I think we will need to maintain some kind of data structure on those points, depending on which of them I choose to be the other yellow point and what will be the answer. But yeah, I didn't finish that. At this point, I switched to problem E. Right, questions? Sorry that I'm not answering now personal questions or just something about the streaming in general or programming, but I focus on explaining solutions to problems. I don't know if I will participate in the next contest. If it's Division 2 only, I will not. General review of the round. Also, are we here on Codeforces? Cool. I don't know, late problems were easy. I spent a lot of time on E. We can see that in my times. So I spent 12, 12, 30, and then what, 10 minutes? And this is, why is this 30? I don't even know why. I experimented for too long. Oh, yeah. If I was faster and I didn't try F, then I should have gotten E as well. So my thoughts on rounds? I don't know, medium problems were easy. What happened with Eknerwala? Why something happened? You know, now being top 20 in the world is bad. And as promised, now let's look at Division 2. I will solve both these problems. I don't know them yet. Also, my face can be back. Division 2A. All right. So AB, let's code this, and then that will be the end of the stream. Actually, I prefer to open it here. I use VirtualBox, virtual machine with Linux. All right. You want to do this with a timer? Replace two adjacent elements of the array by their sum. So from this, 6 and 9 will combine into 15. Or replace the first two elements to get an array 9, 9. Yeah. Beauty is defined as the sum of divisions bi divided by x. Well, I'm guessing that we need to take the initial beauty and the final beauty if we just have a single element. But if that's the case, I don't like the problem. I will start coding, and while doing it, I will explain. There is sum of all elements. This will denote the final value if we merge anything, and singles. We need to round up. This is how you round up when dividing. Okay, I claim that this is solution, and one reason is that otherwise the problem would be very difficult. This is the only thing I see that I can do. 8, 7, it's just the other way around. Okay. And the other, but I think the proof is some complicated math analysis. Is this good? It will not be judged anyway, because still not everything is judged. 235. So we are rewarded for rounding up. We want to, let's say we want to maximize. When we have single values, then it's called that each of them can possibly be rewarded. If we merge them, it will only be worse. Let's say it will be easy to analyze what happens for x equal to 10. Let's say that we have values 7 and 5. Then when rounded up, the divisions will get 1 and 1. But let's say that we actually, okay, let's say that we don't divide, we just care about rounding this up to the nearest 10. This is equivalent, maximizing that. When we have the sum, 12, it will be rounded up to 20. Important thing is, this will not exceed the sum of that. But what can happen, if we have like 7 and 2, this is rounded separately to 10 and 10. If we add this, well, this is only smaller, 10 instead of 20. So we can lose something, because the sum of two numbers, the remainders of the modulo 10 can be that small that they will not give us another 10 when added. This explains my intuition why, this shows why I had intuition that adding will only decrease the value. Right? We add everything. The proof is actually simple. It has simple proof. All right, but still, I don't like it as problem division 2a. This is opposite of what I would want here, because it's very non-programming problem. It's just about proving it or guessing, and half the people will just guess. Or also this. This has nothing to do with programming. This is only math. And I just don't understand, I don't agree that competitions should turn into math competitions. That's like Codeforces rounds. It's okay for math tagged problems. A tag just shows you what's the topic. I just think that this is a bad problem. Tag is, it's not that when slapping some tag here and saying, okay, this tag is real estate, then you can make problem about real estate. This is very far away from a problem where, let's say you are given a tic-tac-toe grid and you need to check who won. This is a programming problem. Well, here we have a math problem. And sure, some balance should be satisfied, but this one is too much on the math side. Right, B. What should I do? My problem isn't judged after system tests. You should just wait. Right, strange list. It iterates over the elements of the, again, division. If Q is divisible, then it splits them into Q over X. Determine the sum of all values of the array. If X is 5 and we have 40, then it will create 8888. And this will not be recursively treated. If it's 50, this will trigger 10, 10, 10, 10. And those will trigger, each of 10s will trigger out of 2s. So 10 gives us a sum of 10 plus 5 times 2. Maybe value of 10 is this. Value of 50 is the answer fit? Will the answer fit in longer? Is 50 plus 5 times value of 10. I will just use this logic. It should be good enough. The complexity will be n times log. I will use recursion and memoization. Even though I'm sure that some formula can be derived. When you care about speed and you see some solution that you know you can implement in 2 minutes, you shouldn't try to optimize it further. You read A, answer plus equal, the value of A when divided by x. Right. Maybe instead of x, I should here just put a single int and clear this map after every test case. It shouldn't matter too much. This is memoization, and now if a modulo x is 0, then this is a plus value of this. Oh. If this is not the case, then just immediately let's return something. Why do I use memoization? Yeah, what's the point? Okay. This is already unlock. I don't know why I wanted to use memoization. Maybe I should have thought for like 10 more seconds before implementing. Oh, this is bad. Did I mess up? You're forgetting that the process can stop? Am I? Oh. Okay, I didn't read this sentence. I didn't see this. All right, I messed up. If all values in the input are divisible, then what? Then we will move to the second layer, then third layer. Well, the memory is fine, so I can just grab them as long as I don't have multiples. Okay. Let's say that we start with a sequence of length n. And those are pairs value, comma, frequency. What do we, sum of values at the end, right? Now, if AFI first is not divisible, break, otherwise, A first divided by X, and the number of occurrences is my number of occurrences multiplied by X. I think this doesn't exceed int type. Go through all the pairs, answer plus equal. Okay, will it work now? No. Seems to work. Yeah, I got 6 minutes. That's quite bad time for a division 2 problem. Yeah, what I'm doing is, if I have a value of 50, I know that it occurs once, then I know that later I will have 10, and there are 5 occurrences of 10, and that will trigger 2 with 25 occurrences. But of course there can be other values. If I have a sequence with 50, 1 and 15, 1, because the input is 50, 15, this is already being judged, then this will trigger 10, 5. This will trigger 3, 5 occurrences of 3. This will trigger 10, 25, and then this will stop. So even if this could be triggered further, it will not. And then I go through the sequence and I sum up all the values. Right, and this is, this is still mathy, but at least it contains programming. I would say that it's bad that both these problems are math related, a bit about division. It isn't a disaster. I would just swap A. I would change A to some problem, just a different problem. It's a bad division to A problem. I think only me and you did this problem this way. Like you talked with others and nobody solved it like that. Right, final standings. No, not final. Running on test 102. Running on test 115. Strange that they have so many tests even though there are test cases. Anybody solved F? I don't know. All right. Probably there are hacks. I don't think there are a lot of hacks. Right, everybody. Thank you all for watching. Am I logged in? I am. Check out the Discord server. This is my schedule of streaming every even weekday. So is wait, Wednesday? That's not true. Should say Tuesday, Thursday, and Saturday. Did I ever stream on Wednesdays? Anyway, this link will work. And if anybody else is doing algorithms, I will rate them. Right. Check out. You can participate with SonarGonu in some short coding game challenges. Thank you all for watching and see you in the next stream. Bye bye. Also, do I have any chance to reclaim Nutella? I don't have the add-on. Oh, maybe it was messed up. Okay, anyway, see ya.